Welcome to Scienceado. In this YouTube channel we provide insights, news, tips and on science, travel and technology topics. Let's get into the video. How AGVs work. AGVs are self-propelled vehicles with movement guided by software and sensors. Most AGVs move along defined pathways, but as mentioned, AMRs typically have more advanced technology with dynamic navigation capabilities. AGV navigation. AGV navigation may be guided using one or more of the following mechanisms. Magnetic guide tape. Some AGVs have magnetic sensors and follow a track using magnetic tape. Wired navigation. Some AGVs follow wire paths embedded into the facility floor. The wire transmits a signal that AGVs detect via an antenna or sensor. Laser target navigation. With this method, reflective tape is mounted on objects such as walls, fixed machines and poles. AGVs are equipped with a laser transmitter and receiver. The lasers reflect off of the tape within the line of sight and used to calculate the object's angle and distance from the AGV. Inertial, gyroscopic, navigation. Some AGVs are controlled by a computer system with the aid of transponders embedded into the facility floor to verify that the AGV is on the proper course. Vision guidance. No modification is required to the infrastructure for vision-guided AGVs. Cameras record the features along the route, and AGVs rely on these recorded features to navigate. Geoguidance. Like vision-guided AGVs, no infrastructure modifications are required for AGVs that use geoguidance. Geoguided AGVs recognize objects in their environment to establish their location in real time to navigate throughout the facility. LiDAR, light detection and ranging, is a sophisticated navigation technology utilizing sensors that transmit laser pulses to measure the distance between the robot and objects in its environment. This data is compiled to create a 360-degree map of the environment, allowing robots to navigate the facility and avoid obstacles without the need for any additional infrastructure. Six River Systems uses LiDAR navigation technology to enable their AGVs to navigate a warehouse without requiring changes to infrastructure as well as to adapt to new environments should the layout of a warehouse floor change. AGV steering. AGV steering is controlled by differential speed control, steered wheel control or a combination of the two. Differential speed control. This is the most common type of steering control used by AGVs. Differential speed control uses two independent drive wheels. Each drive wheel is driven at a different speed to turn. To go forward or backwards, the two drives are driven at the same speed. The simplest steering control option for AGVs, differential speed control, doesn't require additional steering motors or mechanisms. It is commonly used for AGVs that operate in tight spaces or for those that operate near machines. It is not used for towing applications, as it can cause a trailer to jackknife while turning. Steered wheel control. This type of steering control is similar to the steering control in a car or truck. In steered wheel control, the drive wheel is the turning wheel. Steered wheel control is more precise than differential speed control and offers smoother turning. It is often used for towing applications and may also be operator controlled. Combination steering. This is a combination of differential speed control and steered wheel control. AGVs using combination steering have two independent steer-drive motors on diagonal corners of the AGV and swiveling casters on the other two corners. AGVs using combination steering can turn in any direction like a car and also drive in differential steering mode in any direction. AGV traffic control. Traffic control measures include zone control, collision avoidance or a mix of both. Zone control, simple to install and easy to expand. Zone control is a commonly used traffic control method for AGVs. A wireless transmitter transmits signals in defined areas, and the AGV contains a sensor that receives the signal and transmits it back to the transmitter. If the area is clear, a clear signal is sent that allows the AGV to enter or pass through the area. If another AGV is in the area, a stop signal is sent that alerts other AGVs attempting to enter that the area is not clear. In this case, the waiting AGVs will stop and wait until the first AGV moves out of the zone and a clear signal is sent by the transmitter. Another way zone control can be used is by equipping each AGV with its own transmitter, allowing it to send a "do not enter" signal to other AGVs approaching the zone. Collision avoidance. AGVs using collision avoidance zone control are equipped with sensors that transmit a signal and wait for a reply to determine if an object is in front of it. These sensors may be sonic, which work like radar, or optical, which uses infrared sensors. Both work in a similar manner. Bumper sensors are another type of collision avoidance sensor. Many AGVs are equipped with bumper sensors as a fail-safe. Bumper sensors stop to avoid a collision when they sense physical contact. Combination control. AGVs that use combination control are equipped with both collision control sensors and zone control sensors in order to offer more robust collision prevention in all situations. For instance, an AGV may use zone control as its primary traffic control system but also have collision avoidance sensors as a backup in case the zone control system malfunctions. Benefits of AGVs. AGVs offer numerous benefits in warehousing and manufacturing. Increase efficiency and productivity because they operate autonomously. AGVs increase efficiency and productivity, and they're predictable and reliable for repetitive tasks. AGVs eliminate unnecessary walking and also eliminate the physical labor of transporting materials. They set the pace for workers, as well, keeping associates on task. AGVs like collaborative mobile robots guide associates through each task, reducing human error, which helps to improve order picking accuracy and minimize loss and misplaced products. By leveraging AI to optimize routes and prioritize work, collaborative mobile robots improve resource utilization. Consistent costs. AGVs are typically acquired on a per-unit or per rental period cost basis, so there's less fluctuation in costs compared to human labor, which can fluctuate based on market conditions and demand. Flexibility. Some AGVs offer the flexibility of easily changing routes, compared to others which require rerouting guide wires or other infrastructure to adjust a vehicle's route. Automated guided vehicles are a scalable solution, as well, with the ability to add additional units based on demand. Less space required. Compared to other automation solutions, such as conveyor systems, AGVs require less space. Some AGVs are smaller compared to traditional warehouse equipment, such as forklifts, which allows for floor layouts with narrower aisles and better space utilization. Improved safety. Finally, AGVs are a safe automation solution for warehouses, distribution centers and manufacturing facilities. AGVs are equipped with sensors to avoid collisions. Advanced AGVs like AMRs have intelligent routing capabilities that enable them to plan the most efficient path through a warehouse or facility, reducing aisle congestion and preventing injuries. Automated guided vehicles are uniquely designed to automate tasks for which humans are not necessary. They automate long walks in warehouses, set the pace for workers, and eliminate the physical rigors of a traditionally physically demanding job. Chuck by 6 River Systems is a flexible, scalable and cost-effective solution for warehouses and distribution centers offering innovative technology designed to tackle some of warehousing's biggest challenges. Hit the like button if you like this video and share your ideas in the comment section. And of course do subscribe.